We're in the steam section of my garage, although we've moved everything around because U-Coated is doing our floor. So the next time you see it, we'll have a real shiny new floor here. This is a 1925 Doble steam car. This is considered the most sophisticated of all the steam cars, whereas with the Stanley, you have to light a match or a blowtorch, you have to heat it, you have to wait 10 or 15 minutes, easy 10 or 15 minutes. Oftentimes it'll blow up in your face if you've watched some of the other videos. This system is all self-contained. Abner Doble was pretty much a genius. That's a term people throw around a lot in Hollywood, but he certainly was. Because this really solved all the problems that early steam cars had. And to this day, they've never built a better steam car than this. I know this looks a little imposing. What you have here is what we call the steam generator. You might call it a boiler. It's not technically a boiler. You have 600 feet of coil. That's a 6-story building. It puts out 2 million BTUs of heat. You have one single spark plug. What happens is you turn the key, an electric fan forces air up through the venturi where it picks up gasoline and literally throws it into the center of this 600 feet of coil. The spark lights it, and the fire, it fires from the top, not the bottom. Whereas the Stanley heats from the bottom, this heats from the top. You have in here what's called a fire box, which we've coated with modern ceramic materials. I'll show you, we have some video we shot earlier when we had this apart. This is Jim Hall, our fabricator. He built the last burner can for the Doble out of 321 stainless. Now, I understand this stuff is impossible to burn through, isn't it? But look at that.
Pert near impossible to burn through.
Yeah.
The fire in here, we think, must be about 3,000 degrees.
Yeah.
And even 321 stainless doesn't like 3,000 degrees.
We had a we had a probe to measure temperature. It went up to 2,500, and we went, oh, it went to 2,500, and then it went down. We go, oh, it's cool enough. No, the probe melted. It melted. So there's not a metal probe. We have to go to a laser or something. But we think we may have solved the problem. Now Jim made another burner can. Is it the same stainless?
No, this is Haynes 230.
Okay, Haynes 230.
Which is the replacement for Inconel, which
Right.
they built like spy planes out of.
Okay.
Basically, this is space shuttle material.
All right. And the cool thing is this coating. Went to a place called Plasma Coating Corporation of America. They're right here in California. Where are they? In Irvine or somewhere. And they put this on using a laser, and it looks like primer paint. But what it is it's good for 6,000 degrees. Now Jim welded this together. It didn't even distort the coating. I mean, it didn't even turn it brown. So we think this may be the key, and this plasma coating might be the key to any heat problems you're having. Because, I mean, what's a welding torch? How many degrees?
Oh, the plasma of a torch is probably about 6,000 degrees.
6,000 degrees, and look, didn't distort it or anything. So hopefully.
And they tell us this is the same material that they use in the nozzles of the space shuttle.
That's correct. Let me explain how this works. Down here you have, this is what you call your control box. Today this would all be computer controlled, but back in the day it was done with relays. You have a metal tray that sits at the bottom of the fire, and it's got, maybe 4 or 5 quartz rods. And what happened is when the fire gets hot, the metal tray expands, it pushes the quartz rod, which hits this control box, which shuts off your fire. Then as it cools, the rod retracts and the fire comes back on. So you hear the fire go maybe 5 or 6 times, maybe 5 or 6 times a minute, depending on how fast you're going. The car puts out well over 1,000 foot-pounds of torque at the rear wheels. There's no gears, there's no transmission. You've got so much power that you don't need it. Steam, like electricity, makes its torque almost 100% from rest. Once you get your steam goes back to, this has what they call a draft booster, which is essentially like a steam turbocharger. The draft booster, the steam hits it, spins the wheel, which forces air even harder, much harder and faster than the electric motor can, into the venturi, which throws the gas into the generator again. So you're forcing more air and more fuel in, so the fire gets hotter and hotter and hotter. From there, it goes back to a 4-cylinder compound engine. You have a high compression piston and a low compression piston. It then comes back up here through, this is what you call a steam turbine fan. This is not a radiator, this is a condenser. Remember that old experiment when you were kids in science where you'd heat the water and then the steam would come up and hit the plate and then it would turn back into water? Well, that's what a condenser does, basically. The steam gets used to spin this fan, and it's all done very quietly. This is probably the most complicated piece of machinery in my garage. Certainly much more complicated than the F1 McLaren or any of those, because you have so many problems that you wouldn't normally anticipate. Water hammers, all kinds of bizarre things. But it's incredibly fast, it's incredibly smooth. The interesting thing is it almost meets pretty much current emission standards because it's a closed system. It burns, like I said, 2 million BTUs of heat, so all the fuel gets used and burned 100%. This is your oil chest right here. You've got a little filler on there. You fill that with oil. Oh, you fill it up every 6 months or so. That lubricates everything because obviously water is not a lubricant, so you have a little pump that it injects just a dollop of oil into the high pressure steam as it goes into the system. This is an auxiliary unit here. You would fill this with gas. If you wanted to run this thing on home heating oil, you would start it on gasoline. When it got hot enough, then you would inject home heating oil, which was in the day 19 cents a gallon. But I just run it on gasoline because it's easier. Unlike an internal combustion engine where you're trying to get all the heat out of the car, this one you keep running around looking for little places where heat is escaping and then you patch it up. That can be a problem, because with something like this, there's still a lot of rusty pipes. Although we've replaced almost everything, there's still a few original pieces in it. It weighs almost 6,000 pounds. So what we've done, we have mechanical brakes at the rear. When it came from the factory, it only had rear mechanical brakes. What we've done, if you look here, is we put Lincoln drums on it. This car went back to the factory in '29 to have four-wheel brakes put on, but they weren't very effective. What we've done is we've snuck Corvette disc brakes inside the drum, so you can now drive it as a modern car. But come here, I'll show you in our Doble section some of the factory photos and what the engine setup looks like. This is kind of the Doble library. These are the original factory drawings for the compound engine. Here it is here. These two give you some idea of the layout. It's direct drive, literally from the crank to the rear end. There's, as I said, no transmission, no gears, no clutch. These are all the existing factory photos. There might be more, but these are all the ones I could find. There's a picture of Abner Doble right there. Here's basically what your steam generator looks like. Got that out of the San Francisco Chronicle. There is a mighty thrill in the vision of speed. I don't know who that is. That's supposed to be Father Wind or something. I don't know who that is, but he's showing the power behind the steam car. Apparently the car is engulfed in steam, which you can see in the ad. That ran in the newspapers back in '25. They didn't build a whole lot of Dobles. They only built about 40 cars. The thing with Abner was he was a perfectionist. So each car he built, you know, the investors would say, this is great, let's build this one. No, I want to make some changes. And then he would make changes and improvements. So no two Dobles are alike. I would say there's probably no more than 4 or 5 running Dobles in the whole world. So when we have the annual Christmas party, obviously we don't need a big room. I have a friend of mine, Brian Rankin, down in New Zealand. There he is there. That's his car. I've been in touch with him, and he's been in touch with me, and he's been here at the garage. And it's kind of fun because there's a couple of guys in England, there's one in New Zealand, there's a buddy of mine, Stan Lucas, in Long Beach. He's got some Dobles, and they've all been very helpful. Jim Crank, of course, is the Doble guru. He knows more about these cars than almost anyone else, and he's been a tremendous aid. You know, these are the guys I've talked about, like the monks in the old days that used to save the Book of Hours. Well, these are the guys that have saved all the Doble pieces, and I'm very grateful to them. As you can see, everything here is ice cold. This car, well, started from dead, and you'll see how quickly it can make power. See, the reason it makes power so quickly is with a Stanley, you're heating up 15 gallons of water. So you're literally lighting a kettle with a fire, and you're just waiting for it to heat up. With this, you're never heating up more than 2 quarts at a time. You want to heat your steam to 750 to 850 degrees, which is a lot more than a Stanley. And superheated steam gives you a lot more power. But I'll explain that as we get in the car. Hop in. You get in, you pull your handbrake, which opens your drip valve, which lets any water or condensation out of your cylinder. You turn on your ignition. Here we go. Turn on your pumps. First thing you want to do is make sure there's water in the boiler. So you pull this lever here. You can hear a ticking sound. I'm pumping water. I shut it down. I push the pump off. I now turn on fire. I now have ignition. This is my steam temperature. You don't want to move until it's at least 500 degrees. You should be ready to go in under 2 minutes. Howard Johnson originally restored this car. I got it from a lovely elderly lady whose husband had bought it. I don't want to give her name, but she had given it to Howard, who was a steam enthusiast, and he did a wonderful job on the car. When I got the car, we replaced the crankcase and a few other pieces. Howard had to do it on a fairly limited budget, so he wasn't able to do a lot of the things. But he did just a great job, so I want to thank him for that. Oh, this is your throttle. You have a hand throttle and a foot throttle. Whenever people get in this car and don't know about it, I always say, well, this is for smaller turns, this is for bigger turns. But no, this is your hand throttle. The idea being a hand throttle is if a steam valve gets, it can flip over. You know, if suddenly you find the steam is holding your pedal wide open, you can shut it with this, whereas with the foot pedal it would stay to the floor. See, what I'm doing here is I'm making pressure. This is my steam pressure, this is my steam temperature. See the fire, 800, 900, it'll shut off at 1,000. I'll do that to relieve some pressure. I'm up to about 200 degrees here. When it gets to be 500, I'll pull away. Because what you don't want to do is have water in your cylinder, because obviously water cannot be compressed, so you'll hydraulic and you'll pop a cylinder. Take off the handbrake. Okay. Now what I'm going to do now is show you how we fill it with water. Here's that valve I pulled up earlier to pump water. You pull this up and that pumps water, and then when you see pressure rising on your gauge, you put it back to the floor again. This is where you fill up your water tank. Interesting, there are 13 screws around here. The reason I did that was the Rolls-Royce Silver Ghost had 12. And it was thought to be a bit of an overkill, and Abner Doble said, well, if Rolls-Royce is going to have 12, I'm going to have 13. So they put 13 on it. While we're waiting for it to fill up, I'll show you the other side of the motor. As you can see, everything is covered with like an asbestos, or we use furnace cement. You can't really get asbestos anymore. This is my whistle. This is your throttle here. This is your blow-off valve like you have on a Stanley to blow scale out of the boiler. Let's see if the whistle works. Now you may have heard the generator come back on because I took pressure out to blow the whistle, so everything is fired up again here. But what I do now is I fill it with water, and I wait for the water to come out the overflow, and then I know I'm fine. As I said, this is a closed system. That steam you see escaping, that's from the whistle. The valve is not strong enough to hold 1,000 pounds of pressure, so that's why I shut it off manually. But you gotta have a steam whistle. The Dobles didn't come with a steam whistle because there weren't many whistles that could withstand 1,000 pounds of steam. So what we've done is we put a valve in there and tried to reduce the pressure a little bit, and it still gets by, but normally you wouldn't see any steam escaping at all. When you see the water coming out the overflow, that's telling me that the tank is full. Now, Doble claimed you could get 1,000 miles on a tank of water. I don't get anywhere near that, but in the winter you might get 300 miles, and in the summer you probably wouldn't get more than 70 or 80 because the condenser just can't keep up with the heat. But on a nice cool day like today, well, you can reuse the same water over and over again. What they never had, and what they still no one's been able to come up with, is a good oil separator, because once you've injected oil into the water, it circulates again, and you don't want to gum up your condensers. You want to have something to separate the oil from the water. So what you do is you leave the hose in here, and you fill the tank up, and the oil comes off the top. But you don't want to do that easy either, because that's somewhat messy and not particularly environmentally friendly. So what we do is we have these these big diapers, essentially, we put in there. They soak up the oil, and then we throw them away separately. Come on. That steam is only at 500 degrees. You want to get that up to 750 before we put any real throttle to it. Your oil pressure gauge goes to 500 pounds. when you're going down the freeway, you can get as much as 400 pounds of oil pressure because you're using a very thick oil. It's like 600 weight. It's almost like molasses. Unlike a gas car, when it idles, the generator is moving. The generator is not moving when a Doble is idling, because the Doble doesn't idle. When it's stopped, it's stopped. Your generator only turns when you're moving, as you can see here. See, as you can see, when the fire is on, it's pulling electricity. When the fire goes off, it's putting electricity back. There's fuel, there's water, oil pressure. This is like a vacuum gauge. You can see I'm getting up now to 600, 700 degrees. And whereas a Stanley, if you drove it on the freeway at 50 or 60 miles an hour, you might go a few miles, but then eventually you would run out of steam. You'd kind of have to slow down and build up pressure again. Whereas with this thing, you can run 60, 70 on the freeway all day long, holding 1,000 pounds pressure. It makes steam that quickly and that efficiently. When I take my foot off the gas, I don't need fire anymore. The fire's gone out, the pump has gone out. My generator is now charging. When I put my foot on the gas, okay, I'm drawing electricity because both my pump and my fire are on. This is all German nickel, the dashboard, African ivory steering wheel and throttle. This particular car was built by Murphy in Pasadena. It was bodied by Murphy, who also did the Duesenberg. This is a kind of a limousine style. Not my favorite style, but hey, it's a Doble. You grab what you can get. The nice thing is it does have the draft booster, and it's got a very rudimentary kind of a sunroof. As you can see, that opens up, and you can let some of the heat out. These get a little hot in the summertime. There's a lot of steam coming off of that boiler. We've got it insulated, obviously, but it still makes some heat. But in the winter, oh, it's wonderfully toasty. Here's something I recommend to all old car guys. You might want to get these mirrors. I get them at the 99-cent store. They're suction cup, they stick on, and they're wonderful for old cars like this that have blind spots, so you can see exactly who's behind you. I've had all kinds of people come through the garage, all sorts of engineers from General Motors and Mercedes-Benz and Audi, and they look at this and they're stunned about how sophisticated it is for 1925. When Abner Doble was a kid, he went to MIT in Boston, and he built his own steam car with a condenser on it. And he drove it over to Newton to show it to the Stanley brothers of the Stanley Steamer. And they just thought he was kind of nuts, you know, crazy kid. Because he was bothered by all the condensation, all the steam that came out of the back of the Stanley because there was no condenser. The steam all just blew in clouds out the back. So he spent like all day going up and down in front of the Stanley brothers factory, showing them that his car did not put out, you know, plumes of steam out the back. So he was the one that kind of got the Stanleys into putting condensers on their cars. In the day, they used to say they accelerated faster than the Duesenberg. I don't think so, but it's still pretty good. As you can see, you can drive it like a normal car. It's almost as if it has an automatic transmission, because there's no shifting, there's no nothing. You've got such a tremendous amount of power. What you have down here on the floor, this pedal, this has what the Stanley has. It's called the hookup. To save steam, once you're rolling, you push that pedal down like that. You hear a click. You're now cutting your stroke in half, not quite half, but the amount of steam needed to move the vehicle is lessened by about 40%. Steam likes to go at a steady pace, so you get this thing on the freeway and you set your speed, and she's never turning more than maybe 900 RPM, so it's just like a train going down the tracks. See, all you have to do is just barely touch the gas, and you've got such a tremendous supply of torque. You know, I always call steam the hand of God, because it's almost like it just pushes you from the back. It literally just, whereas with gasoline cars, you have to rev them and stuff. This thing you just watch, just the slightest turn of the wheel here. It's almost like somebody just giving you a big shove. What can happen sometimes on a cold day is, if you're only making a short trip, well, all the steam pipes don't get a chance to totally heat up, so you get condensation in the line. So you have little drip valves all throughout the car to drain them. Okay, we've got about 850 degrees of superheated steam. That's about what you want. 400 pounds of oil pressure. Kind of feel like Scotty on Star Trek. She's gonna blow, Captain! She can't take much more! Oh, I can take a lot more. See, a Stanley gauge would just drop. Whereas with this thing, it makes heat so efficiently, even though I have my foot down going 60 miles an hour, I'm actually climbing. I'm actually making more steam than two of these things. Just a fantastic piece of engineering. Gotta remember, this car was built at a time when most cars backfired, made a lot of noise, had huge mufflers. This car was dead quiet. In fact, I picked this quiet little industrial park here because it doesn't seem to be anything going on. And we've got the mic set up real sensitive. So, as you can see, there's no noise when I pull away. Listen. When you want to back up in a Doble, what you do is you have a pedal on the floor here. You see that little pedal within the pedal right there? You push that right to the floor, and what that does is that just reverses your steam engine. Your steam engine is going this way, and you just essentially reverse direction of the motor. And you have all sorts of safety valves and pop-off valves that go off if your pressure reaches too high. I think I've covered just about everything. I know what'll happen is I'll pull this in the garage and go, "Ow! I forgot to mention that." But, well, if that happens, we'll just do another segment. I'm going to leave quietly.